Ladies and gentlemen, welcome back. Let's take a look at pH. So we now know all of the different ways in which we can start to manipulate our H plus ions, our hydroxide ions, our pH, our pOH, and how all those pieces come together. Now it's real important as we work these calculations that we know how to get to each of our different steps along the way. So if we, for example, know the H plus ion concentration, we can solve for the pH if we take the negative log of that value. We know that pH, the powers of hydrogen, is just a logarithmic scale, base 10 logarithmic scale, that gives us some comparison as to how concentrated the H plus ions are in solution. Cool. The pOH then, by contrast, would be the negative log of the hydroxide ion concentration, if you know it. But we know that the pH scale goes from 0 to 14 because they are yin and yang. If we know the pH and the pOH, and we add those together, we know that they must equal 14. Cool. Now, all we need to do is figure out how to fill in our boxes. We kind of know our general waves. We know negative log of the H plus gives us the pH. Negative log of the hydroxide ions gives us a pOH. Let's go ahead. Let's solve this first one. So we've got acetic acid. HC2H3O2. You know it more commonly as, that's right, vinegar. So acetic acid, we know that to be an acid. Now here's why that's important, because that now tells us what the active particle is. The active particle is the H plus ion. So we can go from the molarity straight to the H plus ion. These must be one in the same because it is an acid. Cool. Filling in boxes left and right. All we did was look at what they gave us. I like it. So we know the H plus ion. So if we want to solve for pH, we're just going to take the negative log of that H plus ion. Well, the negative log of that number comes out to a pH of 2.32. Cool. We only got two boxes left. Here's the neat part. We know that the pH plus the pOH must equal 14, must equal this total scale. If we know the pH is 2.32, that 2.32 plus something must equal 14. Well, to find the pOH, we're going to subtract. 14 minus the 2.32 will give us the pOH. Well, okay, when you take 14 subtracted by 2.32, you're going to get a pOH of 11.68 for your pOH. Now some of you are going, wait. We went from three sig figs all of a sudden to 4 sig figs. Remember that when you subtract, you look at decimal places. We had 2 decimal places in our pH, so we're going to have 2 decimal places for our pOH. So now, we're in pOH, we got to get back to the hydroxide ions. We're going to do the opposite of the pH calculation. Here we did negative log of the H plus ions. If we knew the hydroxide ions, we take the negative log of those. Well, we got to do the opposite of that. Well, the opposite of that is the anti-log, which is 10, and we're going to raise that to the power of the negative pOH. And that is going to solve for us this hydroxide concentration. So 10 to the power negative 11.68 is going to get us 2.089 times 10 to the negative 12. So just by following through, keeping all these steps straight, we're able to solve for any of these boxes given just the molarity of our acid. All right, go ahead and pause the video. You try this next line, knowing what you know, following kind of what we did in the first one, and then when you're ready, go ahead and hit press play, and then it'll take you through. I'll show you all those steps to solve for that bottom section. Cool. Let's see how we did. Well, we know we've got calcium hydroxide, and here is the hydroxide concentration. Well, if this is a base over here, is calcium hydroxide, this value must be, sorry about that, must be the concentration or the molarity of our base, 9.45 times 10 to the negative 5th. Cool. And we know it's base because of our Arrhenius definition of an acid or base. We know by definition an Arrhenius base is a substance that dissociates and gives off hydroxide ions in solution. So if we know the hydroxide ions, we can go ahead and solve for the pOH then. Negative log of this number will get us the pOH. Well, negative log of that number comes out at 4.02. Cool. And if we know that pH plus pOH must equal 14, and we know that the POH is 4.02. 14 minus 4.02 gives us a pH of 9.98. Cool. All that's left is to solve for that H plus concentration. Wow, sweet. We know that if the negative log of the H plus gives us this pH, the opposite of that is 10 to the power negative pH. In this case, it's 10 to the power, so the second function log, negative 9.98. When you plug that in, you get 1.05 times 10 to the negative 10. Cool. This is how we solve for our pH, our pOH, our H plus, and our hydroxide concentration. There is one other branch we have kind of been stepping around. That other one is our Kw. Okay? If you want to solve directly from the H plus to the hydroxide ion concentration, we can use what's called Kw. Kw is a constant, equilibrium constant of water at 25 degrees Celsius. That is equal to H plus ion concentration times the hydroxide ion concentration. Now, the cool part is that Kw is a constant, so it's always the same number. So if we know one of these two values, all we'd have to do is take Kw divided by that number to solve for the other concentration. Now, you can solve, it's a square. It's a big loop, if you will. You can solve any of these problems going any direction around that circle you want, whatever you're most comfortable with. Just make sure you follow it appropriately to get to that final destination. Cool. If you have any questions, let me know.